All right, let's get right into it. The entire AI revolution. We're talking everything from massive language models to unbelievable scientific discoveries. It all depends on this one tiny, critical component that most people have never even heard of: high bandwidth memory. Today, we are breaking down the blueprint for its next generation HBM4. This is the stuff that's either going to unlock AI's future or become its biggest roadblock.
So why are we talking about a wall? Because for all the amazing software and algorithms, AI is a physical thing, It runs on actual silicon. And right now, it's about to slam into a very hard, very real physical limit.
And this right here, this is the problem. Just look at these numbers. The demand for AI compute is skyrocketing. We're talking 750 times bigger every 2 years. It's insane. But our ability to actually feed the data to those powerful AI chips, that memory bandwidth, it's only doubling. That huge gap means that more than half of your incredibly expensive, powerful GPU is just sitting there, bored, waiting for data. It's like owning a Ferrari and being stuck in bumper-to-bumper traffic forever.
So to solve a problem this big, you can't just make things a little bit faster. You need a completely new way of thinking. And that, right there, is where HBM4 comes in. This is not just another small step up, it's a fundamental architectural leap. It's designed to blow that bottleneck wide open.
I mean, just look at this. The improvements with HBM4 are absolutely across the board. We're not just getting a little better in one spot. This is a massive jump everywhere you look. The I/O interface? Doubled. The bandwidth is set to just shatter that 2 terabytes per second barrier. We're getting higher speeds, way more capacity, and, this is super important, a huge 20 to 40% jump in power efficiency. But the real headline, the biggest story of all, is right there in that first line, the interface.
The absolute defining feature of HBM4 is this jump from a 1024-bit to a 2048-bit interface. Okay, so think of it this way. It's like doubling the number of lanes on a data superhighway. And this wider road is part of the official JEDEC standard. That's the blueprint every manufacturer has to follow. This standard is exactly what lets a single HBM4 stack push over 2 terabytes of data every single second. For companies like NVIDIA and their next-gen Rubin platform, this isn't just a nice-to-have, it's a requirement to stay in the game.
But here's the thing. As absolutely massive as that speed boost is, it's not even the real revolution. Nope. The most profound change is happening deep down at the very foundation of the memory stack itself. For the first time ever, we are making memory intelligent. So, check this out. On the left, you've got the old way. In HBM3E, the base die was basically just a dumb traffic cop, a simple relay just passing signals back and forth. But on the right, well, that's HBM4, and that base die has been completely transformed. It's not a simple part anymore. It's an advanced logic processor, built in the world's best foundries like TSMC or Samsung. It's like we put a brain at the bottom of the memory stack.
So, what can this new smart brain actually do? Well, for starters, it can manage its own power and handle error correction right on the chip. But the real game changer is its ability to do localized data processing. So instead of just blasting the GPU with a fire hose of raw data, the HBM4 stack itself can actually look at it first. It can filter it, find what's important, compress it, and then send a much smaller, much more useful package over to the GPU. This directly cuts down the GPU's workload, making the whole system way faster and way more efficient.
This incredible new technology has, of course, set the stage for one of the biggest showdowns in the entire semiconductor industry. We've got two titans, Samsung and SK hynix, and they are in an all-out war to dominate the HBM4 market. And get this, they are taking completely different paths to get there.
Let's break down these two competing philosophies. On one side, you have SK hynix. They're the current king of the hill. Their whole strategy is built around stability and maximizing yield with technology they've already perfected. Then you've got Samsung. They're the challenger, and they are betting the farm on scale and synergy, pushing the absolute bleeding edge on every single component. It's a massive risk, but the potential reward is just as huge.
And here's what that looks like in the real world. SK hynix is building this best-in-class alliance. They're using their super reliable 1B generation DRAM, which they know works, and they're outsourcing that complex new base die to the best in the business, TSMC. It's a pragmatic, smart play that pretty much guarantees high yields. Samsung, on the other hand, is taking the integrated synergy bet. They're doing everything themselves. They're using their newer, more advanced 1C DRAM and their own cutting-edge 4nm foundry for the base die. Now, if they pull this off, the synergy could be unbeatable. But Trying to launch two brand new, unproven technologies at the same time, that's a huge risk to their initial production.
The differences go all the way down to how they literally stack the chips together. SK hynix is using its proven advanced MRMUF technology. It's a super stable process where they inject a resin that protects the chips and pulls heat away, which helps them get those great yields. Samsung, true to form, is making this aggressive leap to something called hybrid bonding, a futuristic technique that literally fuses copper layers directly together. It's way more efficient, and it's probably the future of chip packaging, but it is notoriously difficult to get right at mass production scale.
So you see, this is so much more than just a fight over a computer part. The company that wins this high-stakes battle will in effect be writing the blueprint for the physical architecture of artificial intelligence for the entire next decade.
So who's actually winning? Well, right now, SK hynix has a near monopoly. Their stability and high yields are exactly what customers like NVIDIA need today. But just look at this forecast. As HBM4 demand absolutely explodes, analysts are projecting that Samsung's colossal investment in their in-house production power will let them close that gap fast. They're potentially forcing a market tie by 2027. It seems like both the safe bet and the high-risk gamble could actually pay off.
So let's just pull this all together for a second. The fight for HBM4 is about so much more than just memory. By putting advanced logic, that little brain, right into the base die, HBM4 is transforming memory from just a passive warehouse into an active partner in computing. So the winner of this war isn't just going to control the memory market, they're going to dictate the actual physical shape of artificial intelligence for years and years to come.
So it all comes down to this. It's a clash of titans and a clash of philosophies. You've got SK hynix with its stability and pragmatism versus Samsung's high-risk, high-reward, all-in bet on synergy. The question for the future of AI really is which path wins out, the proven road or the bleeding edge?